Start, Akshith.
Okay, sir. Good evening, everybody. I'm Akshith from 9th class. Today I'm going to explain about measurement, which is the topic in the physics. So before going to the topic, we're gonna need to explain. We need to know about physics. So what is physics? Everybody knows physics. It is the main branch of science. So it deals with the many components like force, energy, matter, space, time, etc. So now let's go into the topic. Measurement. What is measurement? Measurement is the comparison of unknown quantity with the known quantity. So there are two main parts of the measurements. First one, it is the numerical value. Second one is the unit. For example, take 5 liters of 5 liters. 5 liters is the in 5 liters, 5 is the numerical value, and liters, which is denoted by small l, is the unit. Next, as in the ancient times, many people used to measure the things with their cubit and handspan. Handspan is the length between tip of the thumb to tip of the little finger, and cubit is the length from tip of the elbow to tip of the middle finger. As it differs from man to man and place to place, so in the 12th General Conference in October 1960, they have decided to bring one international system, which is SI. So it was decided that any physical quantity, it should have these main parts, which is first one, it should be well defined. Second one, its value shouldn't be different from place to place. Third one, it should have a convenient size. Next, last one is that it should be acceptable everywhere. So coming to the physical quantities. Physical quantities are the quantities which can be measurable. And physical quantities are divided into two parts, which is fundamental quantities and derived quantities. Fundamental quantities is also known as base quantities. So examples of fundamental quantities are length, mass, and time. Length, the path between two objects is known as length. Mass is the weight of an object. Time, as there is no definite definition for the time, many scientists have decided to make a simple definition for time, which is the interval between two different actions. Next, coming to derived quantities, which are dependent on the fundamental quantities. Examples of derived quantities are area, volume, density, velocity, etc. So let us take few examples, which is area. Area is the surface occupied by an object, and its formula is the length into breadth. As in the formula itself, it is depending on length, so it is a derived quantity. Next, volume. Volume is the space occupied by an object. So there is a difference between area and a volume. So the formula for volume is the length into breadth into height. It is also a derived quantity. Next, coming to multiples and submultiples. Okay, now let's talk about the SI system and types of systems. So there are four main types of systems: CGS, MKS, FPS, and SI system. SI system is the internationally known system. CGS is also known as French system, which consists, its full form is centimeter, gram, and second. And MKS, which is known as metric system. And FPS, it is a British system, which consists of foot, pound, and second. And MKS is known for meter, kilogram, and second. As there is no definite different values for time. The scientists have considered the same second as a main value. So coming to submultiples and multiples of meter. Multiples of meter: deca, hecta, kilo, mega, giga, tera, peta, exa, zeta, iota. And submultiples of meter: deci, centi, milli, micro, nano, pico, femto, atto, zepto, iotto. Now again, if we go into detail to the multiples of meter, we have decameter, which is the 10 to the power of 1 meter, which is known as 10 meters, and hectameter, which is 10 to the power of 2 meters, which is 100 meters, and kilometer. Kilometer is the 1000th part of a meter, which is 100 meters, which is also known as kilometer. Now, if you go into detail to the submultiples of meter, decimeter, which is 1/10 part of a meter, and centimeter, it is the 100th part of a meter, which is also denoted by zero, which is also known as 0.01 meters. Now let's come to the multiples of kilogram. Multiples of kilogram: quintal. 1 quintal is 100 kgs, and 1 ton or metric ton is is 10 quintals, or is also known as 1,000 kilograms. Next, coming to practical units of length. First one, it is the astronomical unit. Astronomical unit is the distance. It is the mean distance from Earth to the Sun. Its one astronomical unit is 1.496 into 10 to the power of 11 meters. And light year. Light year is the distance of light traveled in 1 year. As we all know, light travels at 3 lakh kilometers per second. And if we'll multiply it by 1 year, we'll be getting light year, which is 9.46 into 10 to the power of 11 meters, 12 meters. Sorry. Next, it is parallactic second or parsec, which it is the biggest unit of distance. It is 3.26 times the light year. Next, coming to the CGS and difference of CGS and MKS systems, we should go to the detail to the derived quantities, which are area, volume, force, energy, power, etc. So the CGS unit of area is centimeter square, and MKS unit of area is meter square. CGS unit of volume is centimeter cube, and MKS unit of volume is meter cube, and so on. So we now the rules for the writing SI system. First one, the unit which is not named in the honor of any scientist should be written in initial lower letters, which is meter, which it is not given in the honor of any scientist. So we will be writing as small m. So next one, which is a unit which is named by the honor of a scientist should be written in initial capital letters, which is Newton, which is the unit of force, which is derived from the scientist name Isaac Newton. So it should be written as capital N. And any unit which are written in short form shouldn't be written in plural forms, like kgs, which we will write as kg, not kgs. Next, relationship between CGS and MKS system. Now for this relation, we will be taking about area. CGS system is centimeter square, and MKS value is meter square. So meter square can be also written as 1 meter into 1 meter, and 1 meter can be written as 100 centimeters into 100 centimeters. So 100 centimeters can be written as 10 power 2 centimeters into 10 power 2 centimeters, which initially turns into 10 power 4 because bases are same. So we need to add the powers. So 10 power 2 into 10 power 2. 10 power 2 plus 10 power 2, which will be 10 power 4, and centimeters into centimeter square. And same as the volume. CGS unit of volume, which is centimeter cube, and MKS unit of volume, which is meter cube or cubic meter. So 1 meter cube can also written as 1 meter into 1 meter into 1 meter, and it also can be written as 100 centimeters into 100 centimeters into 100 centimeters. So 100 centimeters also can be written as 10 power 2 centimeters. So if we'll add all the powers, we'll be getting 10 power 6, and if we multiply all the centimeters, we'll be getting centimeter cube. So relation between the volume of CGS and MKS is 10 power 6 centimeter cube, and also the areas relation between CGS and MKS is 1 meter square is equals to 10 power 4 centimeter square. Now coming to conversions. So to convert a unit into another unit, we need to follow two major steps, which is to convert the following unit into SI unit, and then second step is to convert that SI system into the desired unit. For example, take 5 kilometers to convert into centimeters. So first 5 kilometers, which length in SI system, which is meter. So first we need to convert 5 kilometers into meters, then into centimeters. So like that we need to convert the meters and so etc. Thank you. So that's it.
Very good, Amma.